Hello class, this video covers the last section of chapter 11, 11.8, expected value. Let's look at the formal definition of expected value. An expected value is the value or result you expect to see on the average or over the long run. For example, if you do a survey, you survey all the households at a certain region with 4 children, then what's the expected number of girls in those households? A reasonable expected value would be 2, right? Because half, 4 children, 2 of them are girls. And on average, you expect to see 2 girls in a household with 4 children. And another example, if you go to casino to play a certain game repeatedly, over and over for many years, just to play that one game, and what is your expected gain or loss from playing that specific game? So those are examples for expected value. Our focus of this section is to compute, set up a table to find the value of the expected value, also properly interpret the result of the expected value. So let's look at examples. An automobile insurance company has determined the probabilities for various claim amounts for drivers ages 16 through 21, as shown in the table below. So this example gives us a table structure already. And we need to fill in the last column. Let me explain what's going on in this table. The first column is the amount of claim to the nearest $2,000. So the company do the research. They expect the following possibilities or the following possible amount, claim amounts from different customers. Yeah, maybe the customer do not claim nothing, right, in the next 1 year. Let's see what's the time period. It doesn't really say that. We would just treat that as a certain period. Maybe at a certain period, no claim, right? Yeah, everything's fine. They do not claim anything. Or some customers may claim $2,000, right? Have a car accident, but not very serious. Or $4,000, or $6,000, or $8,000, or maximum $10,000. Probably $10,000 is the cap of the policy. And so the first column, we have all the possible amounts of claim listed here. And the second column is their corresponding probabilities. So the company do the research, they do the research, and they get a result that for a certain customer to claim $0 in the next certain period of time is 70%. It must be majority, right? Otherwise the company goes bankruptcy. And the probability that a customer claim $2,000 is 15%. Claim $4,000 is 8%, $6,000 is 5%, $8,000 is 1%. Yeah, serious car accidents is still rare. So claim the maximum $10,000 is only 1%. So that's the data from the research done by the company, insurance company. And they would normally they have one, they don't need a lot. Normally just one, a very important person do the thing. What's the name? Accurate insure. I need to check the name for that. And they get a very high salary. And the product. So we are looking for the expected value of the claim from a specific from a customer, okay, from a customer. So the first column we have all the possible values for his claim. He might claim this money, might claim this money. That's all the possibilities, and their corresponding probabilities are in the second column. And in the last column, we are going to have the product. Let me explain what is the third column. We are going to multiply in each row. We are going to multiply the amount of claim by the corresponding probability. Okay, yeah, 0 times 0.7, of course, is 0, right? And the second row, 2000 times 0.15. Yeah, let's do that. And let's see if I can use Excel quickly get this done. Of course, you cannot use that. You would have to manually calculate. So if I do this as multiplication, A1 times B1, and I drag down. Okay, so those are the multiplication or the products. Let's go back. All right, so if you multiply 2000 by 15%, 20 times 15, that is 300. If you multiply 4000 by 0.08, 8%, that would be 40 times 8, 320. Yeah, so this is a 6,000 times 5%, so 60 times 5, $300. Yeah, even you manually multiply, those numbers are pretty convenient. Even not convenient, you would have to deal with it. And 1% of 8,000 is 80. 1% of 10,000 is 100. So that's how do we have the last column. And again, our expected value, E. I use E to represent the expected value. Or we can do EV, right? The expected value of like electronic vehicle. So just use E. Would it be the sum? Okay, the sum of the products. The sum of the products. We're gonna add all of them together here. Okay, yeah, the sum of all the products. The sum of the products. Let's see what's the sum of those products. You just add them up, add them all together. Sum from C1 to C6. When you work on your homework assignments or even quizzes, I don't mind you use this method, but you're gonna be aware you can't use it during the test because Excel is not available. So add them all up. You have 1100. That's the expected value. And then let's describe what this means in practical terms. So the company, let's take the perspective of the insurance company. They expect a claim of $1,100 from one customer they developed. From each customer, they expect the customer will claim $1,100 at a certain period of time, or maybe a year. Maybe a year sounds reasonable. Does that make sense? On average. Part B, how much should the company charge an average premium such that it breaks even on its claim costs? Then the company should charge each customer $1,100. Sounds like a 1-year deal, annual deal. Each customer that many money to break even. All right? Does that make sense? Let me repeat the process of finding expected value. All right, yeah. So firstly, we need to make a table, 3 columns in the table. Sometimes I use 4 columns, knowing only those 2 columns. Those two columns. Let me color them, or filling a blue color. Yeah, only those 2 columns give us the probability distribution. Yeah, there's a name in statistics to refer to the table in blue. The first column is all the possible values for the claim, right? Yeah, our random variable here is the claim. It is a random variable because from one customer, we don't know how much the customer will claim, right, in the next year. So it is a random variable. And the first column is all the possible values for the random variable. And in the second column, we have the corresponding probabilities. So together, those 2 columns, that table is called the probability distribution of the random variable x. X refers to the claim from one customer. Does that make sense? Yeah. And on top of that, we add one more column. That's the product. We just simply multiply the value, possible value, each possible value of the amount of the claim, and then by the corresponding probability. And then we add up all the products to have the expected value. All right. Feel why is it like that? Because the probability here kind of like a weighted, kind of like a weight, right? Kind of like a weight. Yeah, $0 weight 70%. Majority of the people will not claim nothing in the next year, right? So basically, expected value can be seen as a weighted mean, is an average weighted mean. And those are weights. The probabilities can be seen as weights for each amount, right? And that's the question number 1. Let's see number 2. Let me put those questions on the next page because it seems a lot of reading. Let's see what's going on in this problem. You are a realtor considering listing a 500,000, so $500,000 house. The cost of advertising and providing food for other realtors during open showings is anticipated to cost you $5,000. The house is quite unusual. That might be the reason it's difficult to sell. And you are given a 4-month listing. You have 4 months to sell the house. If the house is unsold after 4 months, you lose the deal. You lose the listing and receive nothing. You anticipate that the probability you sell your own listed house is 0.3, 30%. The probability that another agent sells your listing is 20%. And the probability that the house is unsold after 4 months is 50%, 0.5. If you sell your own listed house, the commission is 30 grand. If another realtor sells your listing, the commission is half of that, $15,000. The bottom line, you will not take the listing unless you anticipate earning at least $6,000. So this sentence tells us we need to set up a table, probability distribution, to find out the expected earning or the expected value of the realtor's earning by selling the house. If the expected value is bigger than or equal to $6,000, then the realtor should list the house, accept the deal. Otherwise, if the expected value is less than $6,000, then the realtor will not list the house. So that's what's going on in this problem. A lot of words. So good news is this question we have the, oh, this actually is an exam. Oh, it's not exam. Yeah, we need to answer the question. Good news is a lot of data, a lot of information is already sorted by the question already given. Yeah. What happened is, this is what happened. Possible income, I would say possible profit. If gain or loss actually is a profit, right? If the profit is a negative, then it's a loss. If the profit is a positive, then that's a gain. Because the realtor, if he listed the house, he has to pay $5,000 as the cost of advertising and everything, right? So the first table is to organize the possible income of the person. That's the cost. If he sell the house, 30 grand. If another agent sell the house, 15 grand. If the house is unsold within 4 months, $0, right? So the possible profit of the realtor will be the following three values. So we would have the possible profit for the realtor be the following three cases. If the realtor sells the house himself, then the profit would be 30 grand minus 5 grand. You have to use the income to minus the cost to get a profit, right? Yeah. So his profit is 25 grand. If another agent sells the house, then a realtor will get 15 grand, but still have to minus 5,000, and we have 10 grand. That's the profit in the second case. And the last case, the house is unsold within 4 months, then $0. Not just that, the realtor will lose $5,000 because he advertised, right? So those three values are possible, all the possible values for the profit of the realtor. Okay, yeah, we are looking for the expected value for the profit. If the profit is go beyond bigger than or equal to 6,000, accept the deal. Otherwise, decline the deal. So the corresponding probability is given by the question. 30%, 20%, 50%, right? Yeah, knowing those probabilities must add up to 1 or 100%. Same with the previous question. As you can see, all those probabilities, this is 70% and that 15%, 15%, 30%. So all the probabilities in a probability distribution, the second column, all the probabilities must add up to 1 or 100%. If you see they do not add up to 1 or far away, a slightly difference is fine. Slightly more than 100% or slightly less than 100%, that is okay. But if it's far away, that means that's something wrong with the table. Okay, so what do? We are going to add one more column here. We are going to add one more column here. See if I can do this here. Insert a column on the right. Yeah, and then that column is going to be our products, right? Yeah, these two columns, I'm going to color it in blue. That's the probability distribution. That's the probability distribution of the profit of X, okay, of the random variable X. X represents the profit of listing the house, okay, the profit of the realtor by listing the house. So that's the probability distribution in blue. And we add one more column, then we can calculate the product. Yeah, please do that using your calculator. I'm gonna just use the Excel. In Excel, if the value is negative, it's gonna show up in red color. If it's in black, that means positive. So we are going to multiply each profit, each possible profit by the corresponding probability, F1. That makes sense, right? 25,000 times 30%. So 250 times 3, 750. 250 times 30, sorry, my bad, times 30 would be 7,500. And then I'll just drag. Yeah, 10 grand times 20%, so divide by 5, 2 grand. And negative 5 grand, half of them is negative 25 grand. So that is gonna be the products. Yeah, use your calculator. You can also quickly get it done. Put it back. I'm going to change this to negative, not instead of using a parentheses. Okay, then how do we find the expected value? The expected value would be the sum of all the products in the last column. Okay, so we can get it done very quickly. It's $7,000. $7,000. This is a 7,500. This is 2,500. 75 minus 25 is 5,000. 5,000 plus 2,000 is 7,000. If we use Excel to find the sum, G1 to G3, $7,000, right? So what do you think? Should the realtor list the house, accept the deal or not? The question says if the expected earning means profit, is bigger than or equal to 6,000, then he should accept, right? Yeah. So yes, we got a 7,000. The expected value is 7,000. So the agent should accept the deal, or the agent should list the house. Next question. Question number 3, a game. A game is played using one die. If the die is rolled and shows 1 or 2 or 3, the player wins nothing. If the die shows 4 or 5, the player wins $3. If the die shows number 6, the player wins $9. If there is a charge of $1 to play the game, well, the game is not free. $1 cost to play the game. What is the game's expected value? Here, the game expected value of the earning, again, is the profit, all right? Here, we are looking for the expected value of the profit if you play the game. If there is a charge of $1 to play the game, yeah. So describe what this means in practical terms. Okay, so the question already give us a table. I'm going to add one more column in this table, okay? Insert a column to the right, and knowing those two columns in the middle, I'm going to highlight them in blue. Those two columns give us the probability distribution of the profit. Yeah, I use the profit. It means gain or loss, the same thing, okay? I'll just change it to profit. So the first column is the cases or the possible outcomes. So if you roll a die one time, okay, you play the game one time. If you roll the die and you got a 1 or 2 or 3, if you got that, then how much you gain? How much you win? The player wins nothing. Not just nothing, you lose $1. Okay, and now probability is half. Do you agree? It is 1 over 2 or 50%, right? Let me write half. Because the probability getting number 1 or number 2 or number 3, if you roll a die one time, is 3 over 6, which is 1 over 2. And the second possible outcome, we categorize the outcome, okay? This outcome, by the way, I would change this to case because that concept mess up. You might confuse with the outcomes in the classical theoretical probability model. So I'll change that to cases. So we have the following 3 cases. The first case, you roll a die, you get number 1 or number 2 or number 3, right? Then you win nothing. And second case is you roll a die, you get a 4 or 5. You get a 4 or 5, so that is 1 over 3, right? This is 2 over 6 is 1 over 3. And if you get a 4 or 5, the player wins $3. You win $3, but you spend $1 to play the game, so your profit is $2 only. Be very careful. People mess up this part by ignoring the cost of the play. They did not subtract 1. Yeah, remember to subtract 1. And the last case is you roll a die and you get a number 6. And that probability is 1 over 6, right? And if you get a number 6, you win $9. But your gain, your profit is not $9. It will be $8 because you spend $1 to play the game. So your profit is only $8. And you can check again. Those probabilities, 1/2, 1/3, and 1/6 add up to 1. 1 over 3, because that is 3 over 6, that is 2 over 6, that is 1 over 6, 3 plus 2 plus 1 is 6, so 6 over 6 is 1. And the last column is our products. I hope you are watching the video and knowing this section when you work on the assignments or the problem and the quizzes or tests. You want to have a 4-column table. 4-column table. And the first column is the cases. You list the cases, different cases. And the middle 2 columns is the probability distribution. And the last column, 4th column, is the product. Okay, let's see what's the product. Multiply 91 by half, you get a negative 1/2. Negative 1/2. You multiply 2 by 1/3, you get a 2 over 3. You multiply 8 by 1 over 6, you get 8 over 6. 8 over 6 simplified, we have 4 over 3. Let me double check in case. 8 over 6, 4 over 3. Correct, 2 over 3. And that is negative 1 over 2. Okay, so the expected value of the profit, of your profit, by playing the game once is the sum of all the products. That is, let's add them up. Let me write it down. Let me write those numbers. Negative 1/2 plus 2 over 3 plus 4 over 3. Yeah, if we want to add up plus or minus fractions, we want those fractions to have the same denominators, right? The same denominator is better to be the least common denominator. The least common denominator in this case is 6. So we can write negative 1/2 as negative 3 over 6. We can write 2 over 3 as 4 over 6. We can write 4 over 6 as 4 over 3 as 8 over 6. And then we keep the bottom 6 and then add up the top. Yeah, knowing the first top has a negative. Yeah, add those together. So we have negative 3 plus 4 plus 8. And negative 3 plus 4 is 1. 1 plus 8 is 9. 9 over 6, right here, is 3 over 2 and 1.5. Okay, 9 over 6, divide 9 by 3 is 3, divide 6 by 3 is 2. So 3/2 is 1.2. And what is the unit for the one? Because we're talking about profit, money, right? So your expected profit by playing the game is $1.50. So for a reasonable person, if the expected value of playing the game, if the expected value of the profit of the playing the game one time is bigger than 0, then they will go play, right? But if you can try many games in the house, the expected value is a negative, but still tons of people go play just for fun. You never win the house, that's the rule. The house always wins. That's a business, right? So that's the $1.50. That's the expected value of the profit of playing the game. Describe what this means in practical terms. We can say on average, if you go to play the game, you expect to earn $1.50 by playing it. Or in the long run, we can say in the long run, over the long run, for each game you play, the same game, you earn $1.50. Okay, let's see what is this. Unlike the game in the last example, games in casinos are set up so that players will lose in the long run. Yeah, I mentioned that earlier, right? These games have negative expected values. Such a game is roulette. Recall that the wheel has 38 numbered slots, 1 through 36, 0 and double zeros. In each play of the game, the dealer spins the wheel and a small ball in opposite directions. The ball is equally likely to come to rest in any one of the slots, which are colored black, red, and green. Gamblers can place several different bets in roulette. So now you know, playing the game roulette in a casino, your expected value would be negative. Yeah, probably more games than just that. It doesn't mean if you go to play one time you will lose money. It's just a statistically speaking, in the long run, people are expected to lose money because the house is a business. Okay, you see the point. Number 4, one way to bet in roulette, okay, this is about roulette, is to place $1 on a single number. If the ball lands on that number, you are awarded $35 and get to keep the $1 that you paid to play the game. If the ball lands on any one of the other 37 slots, you are awarded nothing and the $1 that you bet is collected. You lose $1. Find the expected value for playing roulette if you bet $1 on number 20. Describe what this means. Okay. Remember I said whenever you process a problem finding expected value, you need a table with 4 columns. Okay, yeah, I'm going to change this, the first column, to cases. I'm not using the word outcomes. Cases. And I'll change the gain or loss as profit. And that's probability. So those 2 columns again make the probability distribution of the profit of playing roulette one time. Playing roulette. And the last column is the product, right? Let's see how many cases do we have. One way to bet, I need to read it one more time about this game. One way to bet in roulette is to place $1 on a single number. So here we place $1 on number 20, right? If the ball lands on a number, okay, lands on number 20. Lands on number 20. You win $35. You do not spend the $1, they will return to you. So your profit is $35. You are awarded $35 and get to keep the $1 that you paid to play the game. If the ball lands on any one of the other 37 slots, other 37 slots, not the number 20, then you are awarded nothing and the $1 you bet is collected. So -1, right? -$1. So only 2 cases? Yeah, let me read the question. One way to bet in roulette is to place $1 on a single number. If the ball lands on a number, you win $35 profit. If the ball lands on any other numbers, you are awarded nothing and lose the $1. So your profit is -1. Find the expected value for playing roulette if you bet $1 on number 20. So this table has one extra row. We can delete that. Delete the row. Yeah. So we only have two cases. Either the ball land on the number you bet on, or not land on the number you bet on, right? So what is the probability? The ball has equal chance to land on any one of the 38 numbered slots, right? So land on 20, the probability is going to be 1/38. And not land on 30 is going to be 37 on other 37 slot, 37/38. Okay, again, you see the probabilities in the second column in the probability distribution must add up to 1. Yeah, I hope you remember that, and that could help you to correctly fill in the table. And then we are going to multiply each row, find the product for each case. So the first row, multiply 35 by 1/38, that is 35 divided by 38. And second row, 91 times 37 37/38 is negative 37/38. Okay, and the expected value of the profit of playing roulette. Let's spell this. ROULETE. Yeah, one time is going to be the sum of all the products. That is, let's add them up. 35/38. Yeah, we're going to add up those two numbers, right? 35/38 plus negative 37/38. And we keep the bottom since they already have the same denominator. And we solve the top. 35 minus 37, right? And numerator is -2. Yeah, let's convert this fraction to decimal. 1/19. Let's convert the fraction to its decimal equivalent. 2 divided by 38. We have, I got a negative 0.0526315789, and we run it because of money, right? We run it to the nearest cents, and it's going to be negative 0.05. It's actually more than that. You actually expect to lose more than just the 5 cents, but we run it to the nearest cents, so we run it down 0.05. So every time you play, you expect to lose 5 cents. Or in the long run, for each game you play, for each roulette you play, you expect to lose 5 cents. Again, this is based on statistics. It's not saying if you go play, you will always lose 5 cents exactly, right? You will lose $1 for one game if you lose. Does that make sense? It's averagely speaking, or in the long run, over the long run. Oh, that's the last question. That's the last question. So you will see more questions about finding expected value. Again, the process are the same. Set up a table with 4 columns. First column lists the cases, different cases. The middle 2 columns are your probability distribution, all the possible values for the random variable and the corresponding probabilities. All the probabilities must add up to 1. And the last column is going to be the products. I have shown you how do we find those products. And then you add those products together, you will have the expected value of the random variable, okay? And that's the guided note for the last section, expected value. If you have any questions, same as always, please feel free to email me. And I'll see you in the next section. Bye-bye.